Hey, hello, Honors Physics. Hey, this is going to be a lecture on how to do question of the day 5.3, which is for November 8th, seeming how I will not be here. All right, so we've got a similar sort of thing. This time we've got a car and it's going around a banked curve, a car going around a banked curve. Now, at the end of this, we're also going to do a flat curve. Now, to give you guys a visual, you guys can see this is the same diagram. This is the same diagram as in your question of the day, right? But if you want to kind of visualize it, so it's kind of coming around like that, right? So you think of NASCAR or something like that. Now, for this particular question, we made the angle 18 degrees. And the question is saying, what is the maximum speed that the car can go on this curve, 18 degrees, if it was not relying on friction? So think about this being on ice, right? So it's going to go the perfect speed so it doesn't slide up or it doesn't slide down. Okay, so one of the key things, as always, for this last chapter and this chapter is drawing a free body diagram. Okay, now this time we're going to have the normal force here, okay? But you guys, we can see here that this part and this part, you guys, this part right here, this is the part that's going towards the center. Okay, so that part's going towards the center. So this is going to be the sum of the forces towards the center, which is going to be mv squared over r. Okay, I'm going to try to fix this. Sorry about that. I'm just trying to fix the glare. All right, regardless, you guys, we're just going to go on. You can probably fill in here. So you guys, we know this direction is going to be towards the center. So that means perpendicular to that is going to be our y, right? So we're going to have the sum of the forces towards the center, mv squared over r. And then up and down this way, we're going to have the sum of the forces in the y. Now, in this case, you guys, as usual, the sum of the forces in the y is going to equal to 0. So essentially, as this car is going around the curve, it's keeping the same height above. So it's not sliding down, it's not sliding up, it's not levitating off, it is not sinking, right? So the sum of the forces in the y direction is equal to 0. Okay, well, you guys, if this is 18 degrees right here, we can do a little geometry and realize that this is 18 degrees. We know that our hypotenuse is the force normal. So that means this part is force normal cosine theta. Force normal cosine theta is going up. And we know that the force of gravity, or mg, is going straight down, okay? So when we are doing the sum of the forces equals 0, we're going to have force normal cosine of 18 degrees, and that is equal to mg. And so now if we divide both sides by cosine of 18 degrees, then the normal force is going to be 1,500, which is the mass of our car. And we're going to multiply that by 9.8, and we're going to divide by the cosine of 18 degrees and our normal force. All right, let's check this out. We've got 1,500 times 9.8 divided by the cosine of 18 degrees, and we get 15,457. 15,456. Okay. 15,456 newtons. Now, you guys, we could certainly round that, but we'll keep that for now. All right. So now we know what our normal force is. And now if we look over here, what is the part of this normal force that's going towards the center? And that's going to be force normal times the sine of the angle, times the sine of 18 degrees. And that right there, you guys, since we're not relying on any friction, that is the part that is going to equal to mv squared over r. Okay, so some of the forces, we're going to have force normal sine 18 degrees is equal to mv squared over r. Okay, now remember, we are looking for this velocity right there. We're looking for that velocity. So we can say force normal sine 18 times our radius divided by our mass, and then we can take the square root. All right, so let's plug in numbers. So we've got 15,456 sine of 18. Our radius is 75 meters. And then we're going to divide by 1,500. All right, let's plug those numbers in. 15,456 times the sine of 18 times 75 divided by 1,500 gives us 242.78. We're going to take the square root of that, and we're going to get 15.6. So our velocity here is 15.6 meters per second. Now, you guys, what's interesting here is if we go faster than 15.6 meters per second, then this car, think of it being on ice, would start to slide up the ramp. Okay, but what also is interesting is if it's going slower than 15.6, then it would start sliding down the ramp, even as it's going around the curve. Okay, so that's kind of that critical angle. That is how you would go around a curve without relying on friction. All right, so you guys, that right there is going to be part one, and now we're going to do part two. So part two says if the maximum speed were 25, at what angle would the bank have to be in order for the car not to rely on friction? So we're essentially going in the backwards direction here. All right. And we are still going to have, we're still going to have this force normal sine is equal to mv squared over r, except we don't know what that angle is, right? So I'm going to erase part of this. And all right, now this is going to become theta. All right, so our force normal sine theta, that's the part that's going towards the center. Okay, well, if we go over here, okay, we're still going to have, and I'm going to rewrite this, okay, force normal cosine theta. Now we don't know the angle, and that is equal to mg, So we can say force normal is equal to mg divided by cosine theta, okay? And now we're going to take this and we are going to substitute it over up here. So now we're going to say the sine of theta, okay? But now we can substitute in this force normal, and we know this force normal is mg over cosine theta. Mg over cosine theta, and that's equal to mv squared over r. Okay, now our m's are going to cancel out. We're going to divide both sides by g. That's going to cancel out. Now we have sine over cosine, which we know is tangent, and that is going to equal to v squared over rg. Well, we don't want tangent, so we're going to say that the inverse tangent of v squared over rg is equal to our angle. All right, so now we know that we are looking for the angle when it's going 25 meters per second. We know that the radius is 75, and we know that the gravity is 9.8. And so we are going to say 25 squared divided by 75 divided by 9.8 gives us 0.85. And now we're going to take the inverse tangent of 0.85, and we're going to get 40.37 degrees. So we'll just round that to 40 degrees. That's equal to our angle. So notice, because we were going faster, that this angle has to go up in order to give us more of the normal force, going straight in. Okay, so this is the answer to number 2, whereas the answer to number 1 was 15.6 meters per second. That's when we knew the angle. Part 2 is we're calculating the angle. Now for part 3, we're going to say, hey, well, what if it wasn't a banked curve at all? What if you were just doing this on a flat curve? But if you were doing this on a flat curve, then you'd have to rely on friction. Okay, so now if we think of our car here, and we would be going towards the center. Now, the force of friction, the force of friction would be the part that would have to be going towards the center. And now we would say the sum of the forces towards the center is equal to mv squared over r. This right here would be relying on the force of friction. mv squared over r would be equal to mu force normal. Okay, and we can see here that the normal force going up, because it's flat, would equal to mg going down. So we're going to have mv squared over r is equal to mu times mg. Force normal would be equal to mg. Our m's would cancel out, and we're going to divide both sides by g. And so our mu would equal to 25 divided by r, which is 75, divided by g, which is 9.8. And you may remember that from over here, except we're not taking the inverse tangent, and that's going to be 0.85. So our mu would be 0.85. Now, would that be kinetic friction or static friction? Now, it seems because it's moving, it would be kinetic energy, but it is static because the wheels are rotating, but it is not sliding. It's not sliding sideways. So even though we've got rolling friction going forward, if it's going to slide, it's going to slide perpendicular to that. And that's the part that's not moving. So this would be static. That would be static friction. All right, and that is how to do question of the day 5.3.